Good day, statisticians. Who would have thought that the skies would open up and the rains would come pouring down and I wouldn't be at school today to have a discussion about statistics with you? Crazy. But, well, that's how life goes sometimes. And so instead of having a regular class, why don't we have a throwback to 2020 and we have class with a pre-recorded video? Why the heck not? And really, it's kind of important, this class today, because we're beginning a very crucial fundamental concept in all of statistics, and that concept is the concept of, here, you ready? Variability. Yes, variability. Variability is what brings us here together today. If it wasn't for variability, there would be no need for us to have a class called statistics, in my humble opinion. Variability is the fundamental, foundational concept of everything that happens in this course. So what the heck is variability? Well, let's it's not that deep. Let's just begin with thinking about something very simple. Have you ever gone to the grocery store? Probably. I assume you have. And when you would go to the grocery store, it's sort of the end of an aisle. Sometimes you'll see a person sort of hanging out there, right? So here's this happy little person, right? They're standing at the end of the aisle and they've got some kind of like little table and, they're smiling. And then there might be like little cups of something. And in those cups, they've got like little products. And then you might come up to there and be like, oh, hello, what do you got there? And this person says, ooh, would you like to try some? Would you like to try some of this product? And, maybe it's something like these. I was just raiding my pantry this today as I was realizing I was going to have to record this lesson. I was like, what do I have in my pantry? But what if it was something like this? Here we've got some goldfish mixed crackers. It's a nice mix. We've got some cheddar and zesty cheddar and Parmesan. Right? So you're at the grocery store and someone offers you this. Said, would you like to try some? Well, why are they doing that? Are they just being nice? Like, here, just have some product. Do they think you look hungry? No, they're offering you a little taste, right? Because why? Well, what do we call this? Well, we call this a free, what is this? This is called a free sample, right? And why are they giving you a free sample? Well, they like to think that if you take a little taste, you get a little try of this, maybe you'll want to buy the product, right? You can buy the product. So you might go in there and that'd be great. So this little common experience for us is actually just like something that we think about in statistics in a more rigorous scientific way when we think about this process of just getting a little taste and learning from a little bit of a taste, right? So in general, in statistics, we talk about a large group that we're trying to understand. And we call these large groups that we want to understand as a whole a population. Right? So a population would be an entire group of individuals we wish to study. So for instance, in this particular example, I might want to try to understand all goldfish mixed crackers, all of them. Now, all of them is a lot. Like this bag, I don't know, I could probably kind of count. Let's see, a serving size is 1 pack. That doesn't tell me how much is in the pack. I don't know, there's probably like at least 30 or so crackers in here. But there's a heck of a lot even more than that. I mean, this is just one little bag of tons. So the whole population of all goldfish mixed crackers is thousands and thousands and thousands of these crackers, right? So that's a population. Now, I could try to learn about that population by taking what we call in statistics a census. And you guys have used that word before. A census is a procedure that collects data from an entire population, from a whole population. So I could take a census. I could say, I want to figure out if I like these goldfish crackers with a census. Well, is that plausible? What does it take to take a census? Well, I'd have to, I mean, you can think about it. Have you ever gone to get a free sample and you get one? And the person says, oh, what do you think? Do you like it? You're like, yeah. But do you think I could have, I mean, that was an interesting taste. Fine, sir, offering me these free products. Do you think I could have another? What do you think he'll say? Well, maybe he'll say, shh. I guess so. I guess you could have another one. Don't mind if I do. You know what? The first one was interesting. The second one was also interesting. Do you know what I need? I think I need a third. At that point, is he going to give you a third one? Probably not. He's going to say, guess what? You already took a sample. Yes, in statistics, we use that same word sample. A sample is just a smaller part of that population, a subset of the population. So a subset of the individuals in the population from which we collect data, right? And so you took a sample of, say 3 little taste of these chips. Do I need more than that to figure out if I like them? Do I need to take a census? Do I need to eat all cheddar, zesty cheddar, Parmesan mix crackers to know if I like them? And you certainly don't. You don't need to eat them all, right? Because, well, from one cracker to the next, they're not necessarily all that different. There's not necessarily all that much variation, not necessarily all that much variability. There is some, but it's not there. So there's an interesting idea in statistics is that clearly if you want to understand an entire group or an entire population fully, without any doubt whatsoever, you're going to want to take a census, right? However, oftentimes taking a census is impractical. I mean, would the goldfish company be in business very long if in order to, well, maybe they would be in business for a long time. If I bought all of the crackers, as long as I paid for them, maybe they would be thrilled with me taking a census of their crackers. But no, I mean, you can't just taste them all. That's just ridiculous, right? And it's not even necessary. We know it's obvious to us that you could take just a small subset of these crackers and you could figure out that whole population. And so there's this interesting idea of variability. Now, when it comes to crackers, it's sometimes different with crackers than it is, say, with people. And so let's take a step back. There's another concept for us to think about, that when we look at a population or a sample, when we look at these individuals, there's always something that we want to know about them. Like, for instance, I might want to decide, are these tasty, right? And that would be something that we would call a variable. So we've talked about variables in all your math classes so far in your life, right? You're always talking about variables. Whenever you hear the word variable, you almost certainly think of a particular letter, the letter X, right? And X could stand for any number. Well, in statistics, a variable is very similar. But variables don't necessarily just have to be numbers. A variable is just any characteristic of an individual, right? And so I could define a variable in terms of, say, the tastiness, like the tastiness of these crackers. Is that how you spell tastiness? I think it is. The tastiness of these crackers could be a variable, right? And you might break it down into one of two categories. You could either say one value of the variable is that it is tasty, and another value of the variable is that it is not tasty. You might turn it into this binary kind of thing. It's either tasty or not tasty. And these are the two possible values of the variable tastiness. That is a variable. That's a characteristic of an individual. And we call it a variable because it's something that could vary from amongst different individuals in a population. Now, when I taste these goldfish crackers, they don't vary that much. There's not a lot of variability. They pretty much all taste the same. However, if we extend this to other examples, say I'm asking the opinion of a human being as to whether or not they find these guys tasty, there might be some variability there because different people have different kinds of opinions. Which has more variability? Goldfish crackers or humans? Definitely humans. Humans have much more variability. One human to another is very different than one goldfish cracker to another, which causes problems for us. It's pretty easy to figure out whether or not you like goldfish crackers simply by eating one or two goldfish crackers. It's pretty hard to know whether or not someone is going to win a presidential election just by asking one or two people. Because while one or two crackers are basically the same, one or two people could be very different from each other and from the population as a whole. There's lots of, what's the V word? Variability. Right? And so we use the word variable in statistics, similar to how we do in other math classes, but it's fundamentally saying that there's some characteristic that can vary from one individual to the next in the population we're looking at. Now, we'll make some distinctions here. The variables that we talk about could be in two kinds. Sometimes we have categorical variables that simply place individuals into a group or category. And that's basically what we have right here when I was looking at the variable of tastiness, which, again, I guess that's how you spell it. I mean, why not? Tastiness right there. Then this variable is categorical. I'm placing these crackers into one of two categories, tasty or not tasty. But most of the time in math classes, we tend to think of quantitative variables. That's where the variables take numerical values, presenting measurements, which would be kind of continuous quantitative variable, or a count, which would be a kind of discrete quantitative variable. And we'll talk more about that distinction later. For instance, another variable, instead of just the tastiness of these crackers, might be, let's think of something quantitative. Well, I could see, it says on this package that the net weight is 26 grams. 26 grams, that's how much it weighs, right? That's something that we would measure. That would actually be a continuous quantitative variable. Now, let me ask you this. Do you think that every single one of these bags of goldfish mixed baked cracker thingies weigh exactly 26 grams? Like every single one of these bags, it says on the package 26 grams. Is it always exactly 26 grams? Well, probably not. It's probably close to 26 grams. Maybe on average, it's usually about 26 grams, but it's not always exactly 26 grams. There's some, what's the V word? Variability from one bag to the next, but not a whole lot. Probably a very minimal amount. We also might say count something. Instead of like measuring, say, the weight of all the crackers, you might try to count how many are in the bag. Now, I've already been eating these, and I'm not going to count. But that would be a discrete quantitative variable, where you would count. And there might be variability there. Do you think every single one of these bags always has the same number of goldfish crackers? Probably not. It's probably pretty close, but there's probably a different number in different bags. Maybe sometime we'll bust out some goldfish cracker bags or something like that and put it to the test and see how consistent they really are. But this is this fundamental idea, right? If you wanted to know how many goldfish crackers are in one of these bags, would it be enough to just look at one bag? Well, probably not. If you want to know exactly how much do the crackers weigh in these bags, is it enough to look at one bag? Again, probably not, because there's probably, what's the word? Variation. However, if you want to know the tastiness of these crackers, you probably can get away with maybe just one or two crackers, because there's a lot less variability in the tastiness of the crackers than there might be in the weight or in the number of the things. And that's just thinking about crackers. Again, thinking about more complicated things like human beings, there can be a lot more variation. If you want to know a presidential election, how many people do you need to ask before you can be confident that you can predict who the winner is going to be? Well, probably more than one or two, right? And so this leads us to some other core concepts in statistics as a whole, right? We can, when we think about statistics, and we're trying to understand a variable in a population, a measurement of a variable in a whole population is something that we call a parameter. A parameter is some number that describes some characteristic of a population, right? And so that would mean that we took a census and we summarized a variable for every single member of that population. Here's an example. During the 2015 to 2016 season, Matthew Dellavedova scored an average of 7.5 points per game. Why did I use him as an example? Actually, I had one of my students named Bella some years ago. I think she was 276. She said that I look like Matthew Dellavedova. and anyway, so I always thought that was funny. So anyway, Matthew Dellavedova. So that is a parameter. It's a numerical measure of a characteristic, right? What is the variable? Well, we were looking at the number of points, points scored by Matthew Dellavedova, and we have a parameter. We know that on average, his average number of points per game was 7.5 points. That's very good. That was based on every single game that Matthew Dellavedova played. We took a census and we have the average calculated for the whole population. That's called a parameter. Now, let's say though that I didn't collect information from an entire population, and instead I collected only information from a sampling. That is what we would end up calling a statistic. So a number that describes some characteristic of a sample. So for instance, this guy, even though we often use the word, say, a statistic to describe this sort of fact about Matthew Dellavedova, it's not an actual statistic at all. It's actually a parameter because it was based on a census. Something is only a statistic if it's based on limited information. So this course, statistics, is really about the situation where we take a sample and we have a limited taste from a population. This class is all about free samples, about getting, well, maybe oftentimes the samples that we collect are not free. We got to pay for them. It costs companies lots of money, or governments lots of money, or us lots of money to collect the data often, right? So it's not free, but it's all about taking a sample. So statistics is fundamentally about the situation where we can't take a census. We take a small taste from a sample, and then we calculate some statistic as a substitute for calculating that parameter. So that here's an example. According to a July 2017 study by the Pew Research Center of American Adults, 41% of respondents have personally experienced online harassment. Well, it's unfortunate. That makes me sad. This is an interesting statement, though. So it says, according to this study by the Pew Research Center, 41% of respondents have personally experienced online harassment. Now, the way they're wording this, it sounds like this would be a parameter. Now, why do I say that? It's saying 41% of people in America. But hold on, this isn't a parameter. Why? Because it's 41% of the respondents, right? This is a percentage that was calculated based on some sample. How big was the sample? Off the top of my head, I don't know how big the sample was, but it's certainly, do you think they asked every single person in every single American adult in July of 2015? I was an adult in July 2017, and no one asked me whether I have ever experienced online harassment. So this was not a census. The statement is a statistic because it was based on a small subset of the population. So here's this thing. We've oftentimes, we really don't know parameters, right? In most situations, the best we can get is a statistic rather than a parameter. And so, why? Because it often is very difficult, very time consuming, very costly to take a census. And we have to be satisfied with a smaller sample from a population. And so when we want to know a parameter, though, we oftentimes will try to make, say, an estimate or a guess about what that parameter might be based on a statistic. And that's fundamentally what we call inference. It's drawing a conclusion that goes beyond the evidence or the data that we have in hand, right? Where we're trying to make some kind of generalization or some kind of prediction based on what we see here. So we saw in this sample, right? So this is a little sample statistic. This little P with a little thing on top of it, that's actually called a P hat. And we'll talk about that later in our course. We saw in this study a P hat of 41%. But from this, we might want to estimate P, right? Which would be like the actual percentage of all American adults that experience online harassment. Now, if I had to guess, I would guess that P is probably close to 41%. But not exactly 41%. I mean, I don't want it to be 41%, but assuming that this sample is well representative of the population, that it gives me a good snapshot, just assuming that the couple crackers I tasted here are representative of all of these crackers, I can hopefully get a pretty good idea. So the truth about P, what I'll call the true parameter of the whole population that has experienced online harassment, hopefully that would actually be close to the statistic that we actually observed in July 2017 by the Pew Research Center of 41%. So that's inference. And so what we end up often doing is we end up trying to estimate a parameter based on a statistic. Do we always have to estimate our parameters? No. Depending on the variable that we're studying and the population that we're looking at, sometimes we don't have to estimate the parameter at all. We can easily know it. For instance, with Matthew Dellavedova, I could look at all of his games in 2015 to 2016, and I can calculate his exact average. That is called a parameter. But in general, this is sort of the pattern of statistics, right? We have some population we want to study, then we have to take a sample from that population in order to understand the population, and we therefore, through collecting some type of representative sample, we can draw an inference where we can estimate a parameter based on a statistic, right? And my friends, that is the fundamental core idea of statistics, that because there is variability, because the characteristics because the characteristics of individuals and the populations that we want to understand vary, one person is different from the next. Sometimes even one cracker is different from the next. We need to somehow collect just enough of a sample to understand that whole population, but always being aware that we'll have an imperfect picture unless we are able to take a census as a whole. All right, my statisticians, I hope this was an interesting and helpful introduction to some core vocabulary. I hope this was sufficient for you to be able to complete our assignment, and I hope you have a very beautiful day. And I will catch you hopefully tomorrow. Have a very, very beautiful afternoon, and catch you on the flip side.